Insulation is the most important part of the generator. Basic concepts of the insulation are explained in this video. Main component of the insulation is mica. It is the only material which is a good conductor of heat but a bad conductor of electricity. It has got excellent dielectric strength, low power loss factor, is incombustible, can withstand high temperature, etc. But mica is brittle. It is processed and converted into either mica splittings or mica paper. But mica splittings and mica paper don't have sufficient mechanical strength suitable for taping. Mechanical strength is provided by a backing material. Mostly epoxy resin is used for binding of mica paper and mica splittings to the backing material. It is used as it has got high penetrating power. The class of insulation is decided by the resin. The class of insulation means the temperature it can withstand. These are denoted by Y, A, E, B, F, H, C. For example, class B can withstand temperature of 130 degrees centigrade and class F can withstand temperature of 155 degrees centigrade. Nowadays, mostly class F insulation is used. In most customers' specification, it is written that class of insulation should be class F, but temperature rise be limited to class B. The customer is absolutely right. Insulation is very sensitive to temperature. Every 10-degree rise above the permissible temperature reduces the life of the insulation to half. In class B insulation, permissible rise in the generator is 70 degrees centigrade, considering 50-degree ambient temperature and 10-degree margin for hot spot temperature. Let us understand hot spot temperature. RTD and resistance method are normally used to measure temperature of winding. These give an average temperature. At a local point, there may be higher temperature. This is called hot spot temperature. 10-degree margin takes care of hot spot temperature. In colder countries like Europe, ambient temperature is 40 degrees centigrade. Hence, temperature rises 10 degree more, that is 80 degrees centigrade. Earlier, thermoplastic insulation was used. Nowadays, thermosetting insulation is used. Thermoplastic means it softens with therm. Thermosetting means that it sets with therm. Resin-rich system means that insulating tape is rich in resin, whereas resin-poor system means that insulating tape is poor in resin. Earlier, resin-rich insulation was used. Straight portion of the coil was wrapped with resin-rich tape. It was pressed under heat and pressure. Resin is cured by heating and straight portion of the coil becomes hard. However, the overhang portion of the coil was insulated with flexible tape. This helps in easy insertion of coils in the stator slots. After curing of straight portion of the coils, the stator coils are inserted into the stator slots. In the resin-poor system, coils are insulated with resin-poor tape and coils are inserted into the stator slots. The complete stator along with coils is put into the impregnation tank. First of all, vacuum is created to suck the moisture, etc. Then resin is filled in the tank. Nitrogen pressure is applied to impregnate the stator completely. Nitrogen and excess resin is removed from the tank. The stator is shifted to the curing oven. Resin in the insulation is cured by heating. This process is also called vacuum pressure impregnation process. First vacuum is created, then resin is impregnated by pressure. In Siemens, the trade name of this process is called Mica. It is also called global impregnation as complete stator along with coils is impregnated. In the large size generators, e.g. 500 megawatt and above, global impregnation is not feasible and stator bars are impregnated in a group. Stator bars are fixed in a fixture. The fixture is put in an impregnation tank. Rest of the procedure is same as described earlier. There are a number of advantages of resin-poor system. It produces wide-free insulation, it has got higher dielectric strength, it reduces vibrations, it prevents ingress of foreign particles, and it improves heat transfer. One of the methods to assess the health of the insulation is tan delta. In stator conductor, there is an AC voltage and core is at earth potential. Thus, this becomes a capacitor, as there is a voltage difference between the conductor and the core, and there is insulation in between them. Ideally, there is only a capacitive current. In an ideal capacitor, capacitive current leads the voltage by 90 degrees, but insulation absorbs dust and moisture. These create conductive paths in the insulation. Hence, the resistive current also flows in the insulation. Resultant current forms an angle delta with capacitive current. Tangent of this angle is called tan delta. It is a ratio of resistive current to the capacitive current. In case the tan delta is more than 2% at 0.2 times the nominal voltage, one must be alert. Higher resistive current produces heat in the insulation. Heat affects the life of the insulation. Tan delta can be improved by heating to remove moisture and cleaning with petrol to remove dust. Normally, shearing gauge is used to measure tan delta. Tan delta is also called dissipation factor. Delta is also called loss angle. Tan delta is applicable for AC only, not in DC. HV test on the complete machine is done at 2 kV plus 1 for 1 minute. Repeating of this test should be avoided as it affects the insulation. In case the customer insists, HV test is repeated at 80% of 2 kV plus 1. As the insulation topic is very vast, other topics related to insulation are covered in further videos.